Question number 21. Diagram shows a transverse wave on a rope. The wave is traveling from left to right. Okay. At the instant shown, the points P and Q on the rope have zero displacement and maximum displacement. So this is having a maximum displacement, this is having a zero displacement, right? Which row describes the direction of motion if any of the points P and Q at this instant? Now he is asking you, see, the wave you get is only because of the vibration of the particles, right? So the particles are vibrating over here. So that instant, okay, so which one is actually at rest, okay, or is it moving? So what is happening over here? That's what is the question. So what I do is I consider this sine wave to be produced by a simple pendulum, for example. This is how a simple pendulum looks like. Now as a result of it, when you say this is a stationary wave, a transverse wave is being produced over here, okay, this can be considered to be equivalent to that of the motion of a simple pendulum. Now what happens? When do you get this point? You get this point, okay, this when you get this extreme over here, that means the amplitude is higher, right? So a simple pendulum is producing a transverse wave and this amplitude is higher. So this is nothing but your point Q and this should be a point P. Now see, because you get an amplitude to be 0, instantaneous displacement of the point P is 0 and instantaneous displacement of point Q is maximum over here. So when the particle is at this point, when you consider the point Q, that means the particle is at this point. Now what happens to the point at this point? The pendulum goes to this extent, waits for some time, then transverses or it comes back to its original path, right? So therefore this will be stationary for a moment, okay, for the next 1 microsecond this will be at rest. But what about the point here? This will now start moving in this direction, okay. So as a result of this, this will be moving and this will be stationary. So therefore this is incorrect and upward stationary is also incorrect. Point Q. So now I have got stationary and stationary. Now the question is whether point P is moving downward or upward. That's the next question. So towards it, when you say the wave is moving like this, what I do is what is the next point? Let me say this is the peak initially. At t equal to 0, when you took a picture, this is like this over here. Now next time is the moment after 1 second, after 1 microsecond. Where will the peak be? Peak would be here. Which means what? You will see the wave like this. You will see the wave going like this. Right? You will see the wave going like this. This is the wave. You trace the wave like this. It will be going like this over here. It will be going like this. And it goes like this over here. This is the way how it goes. So now what you do is drop a perpendicular here. What do you observe? The point P which was here, the next instant, the point P appears to be at this point. Which means what? The point P has gone down. Now if you can always argue saying that, okay, why don't you apply the same thing here also? Okay. When you apply it here, now you see, here it is on a linear path. If you zoom this one up, you see this one will appear to be something like this in a straight line. But if you look at this point Q over here, this will almost be a plateau region over here. Okay. So in the same 1 microsecond, this might move a larger extent as compared to this. This Q would have moved to this one. Approximation, what you can do is you can approximate this and say might be the distance moved by Q is almost a plateau region, but here it will be moving downwards over here. Okay, thus you can say point P moves downwards, point Q appears to be stationary. Strictly speaking, it will not be stationary. If you go for something like nano level or femto level and so on, definitely this also appears to be a little bit more. But unfortunately, this region appears to be a plateau region over here. Okay, see, compared to this one, see, in physics, what we need to do is we always need to do a comparison. So when you do the comparison, compared to this, this does not appear to be moving downwards. It appears to be moving on a straight line. Okay, so thus we can now say answer A is the right option.